In this recording, we're going to talk about how to algebraically find the inverse of a function, given its equation, specifically as it relates to quadratics and radicals. So, let's identify the steps. This should be a review from before. Okay, and in essence, if you remember nothing else, remember switch x and y. So let's write out the steps. First, if it's not written as y equals, we need to get it into y equals form. Next, we switch x and y. Next, we need to solve for y. And finally, we need to express the inverse in appropriate notation. In other words, if it's h of x, we express it like this, inverse of h of x. If it's a y equals, we express it with a y with a -1 superscript, meaning the inverse of y. Okay, so let's attack this inverse of a quadratic function here. So this quadratic function says, whatever you put into the input, square it, and then add 1. And we want to undo those operations, but it's not so simple as unsquare rooting and then unadding 1, because we have to think about the order. So in order to undo this, what we're going to do is create a function that's equivalent, but uses y equals. Okay? And then what we can do is switch the x and y. I'll change colors here. The x takes the place of the y, and the y takes the place of the x, and that's it. They literally switch x and y. In other words, now this squares on the y. Now we need to get y by itself, so we can find the inverse here. So we're going to subtract 1 from both sides. That'll give me an x minus 1 equals y squared. Then I want to undo the squaring. Okay, so I'm going to square root both sides. Okay. When I square root a square, keep in mind we get the absolute value of y. I'm just going to sort of switch sides here. Okay. And that's going to result in a plus or minus square root of x minus 1. Now keep in mind here, we have a domain restriction such that x is greater than or equal to 0. So if you think about it in terms of parabola, it's only this part of the parabola. So I can't have the plus or minus square root of x minus 1. That'll give me essentially a radical function like this. Well, let me start over, because my parabola is a little imprecise. Let me start over with that parabola. My parabola would be down up here, right? It would be shifted up 1, and so my radical function would be shifted right 1, so it would be something like this. Those look like they're inverses, right? But if I keep the plus or minus, now I'm down here also, and that can't be the inverse. Okay? Those don't look like inverses right now. So I'm just going to keep the top part. And so what I'm going to say is h, or the inverse of h of x, is equal to the positive only square root of x minus 1. Okay? And I don't need to say where x is greater than 0 here, because I have that built in. Obviously, there is a domain restriction built into this. X cannot be, x has to be greater than or equal to 1. Otherwise, we have we're taking the square root of a negative. Okay, but that's sort of implied in there. All right, now on this one, on our fifth root, you might say, that's crazy, I've never dealt with a fifth root before. Today's your lucky day, you get to deal with a fifth root, right? And really it's no different than a cube root or a square root. We're still going to undo it by some sort of power. Okay, so let's get started and see as far as you can get, and then play the recording. So if you did a y equals, and you have the original fifth root of 3x minus 7. And then you're going to switch your x and y. Okay, so you got an x equals fifth root of 3y minus 7. Okay? I want to undo this fifth root. Okay? So think about how to undo that. Well, same way you'd undo a square root, right? You would square. So we're going to undo the fifth root by raising both sides to the fifth power. That's kind of cool, because that gives us an x to the fifth. Okay, and now it's pretty much an easy solve, right? We're going to add 7 to both sides, and then divide by 3. And then divide by 3 on both sides. Okay, so finally, in terms of writing it in appropriate notation, as we had said, it was originally called g. So I'm going to express it as the inverse of g of x is equal to that fraction. Okay, and I do need to restrict this. Okay, the original function was restricted in such a way where x had to be greater than or equal to 0. And what we're going to do is restrict this in such a way where x is greater than or equal to 0 as well. Finally, how do I know I'm right? Okay, I want to demonstrate that two functions are inverses. We can do that in a few ways. We can do it numerically, we can do it algebraically, and graphically. Okay, so numerically, what we talked about in the last video, kind of subbing in a number. I'll give you an example here. If I sub in a number here for x, say for example 5, and I do 5 minus 1, which is 4, square root of 4, which is 2. Now if I take that 2 and put it up into this function, 2 squared is 4, 4 plus 1 is 5, right? I get back to where I started. Okay, so essentially, numerical, I pick a number here like 5, for example, inverse of f, or f of the inverse of f, of 5, comes out to be 5. And, conversely, the inverse of f of 5. Now that's a lot of notation for a person to handle, but keep in mind, all that means is we're undoing it. It's like you start with your shoe off, you put your shoe on, and then you take it off, you're back to no shoe on, right? You did the inverse with its original function. Now that's using it with a particular example, okay, of an x value. Now algebraically is showing it works for all values of x. Tough one for me to spell. And that one is abstract. We're not going to do as much with that in this course, but okay, you can see how basically just replace the 5 with an x, and I have to do this symbolically. Okay, so I'm showing that it works for every value of x. And the last way we can demonstrate is by a graph. So take a moment right now to think about what relationship you know exists between any function and the graph of its inverse. And so hopefully you recognize that they are symmetrical about the line y equals x. Thanks for watching.